Okay, it looks like we are live, so welcome back. Today I'm going to be continuing to work on KinoScript. Yeah, so last stream, I was working on getting it so we can, call C libraries from KinoScript. So I have a small example here. So the C library looks a little something like this. It's just a very basic one, just for testing. We have this, and then you have to write basically a wrapper around it, the C code, which, this should be able to be automatically generated, and that is the plan. But we have this, this here, which basically interacts with the virtual machine, to do operations on the stack, and then call call the function here, which would be the library function, right? So if it's raylib or whatever, anything like that, it would be called here. So that's what it can do, and we can change this and all that. But then in KinoScript, we have something like this. Now this is just temporary. We're going to be working on that today. But basically, I introduced two different built-in things essentially. So DLL, and that is to define a dynamically loaded library, right? So we have, this is the name of the library, of the file of it, and then this is the function name that you want to call, and then we actually call it with the argument. Now this is just temporary. It's call, and you don't pass any other parameter about it. So I'd like to be able to do call, native add 10, like you would define it as a function, something like that. Maybe not exactly like that. And then you can pass the arguments to it as well. But yeah, for now you cannot do that. So you can put 10 here, right? So that's going to do add 10 to 10. So if I run that, you can see it does this and it adds 10 to 10. But if we change this, so say we want it to, I'm not going to change the name, but if we want it to add 20 instead, and then we rebuild that, so we can do, I forget how exactly. Like there's a few different things that we have to type out. And yeah, there's one more flag that we need. We need pick. And there we go. So then if I run it, yeah, it's 20 instead, right? So it loads the library dynamically. We don't have to recompile the KinoScript compiler. Instead, we can just load the code in there. Now this is useful for a number of things. Right. Essentially, any modern language that you make, it's going to need to call C code because C is so important, and there's so many things that basically are written in C that it'd be really nice to be able to call. Like for example, if you want to make a game, say you would use something like Raylib, you'd be able to create bindings for it, to call Raylib from KinoScript, and then you can make a whole game like that. And I would like to make at least a small demo game to test out once this feature is more implemented. But let's see. So what I like to do today is sort of make this a bit nicer. Let's see. So I want this, right? So instead of typing out call, you instead type the name of the function that you define, the external function. So it would be native add 10, and then you pass all the arguments, you know? So yeah, like 10, like that. You call it like that. So that's how you know how to call it. So we'd have to add this name to something. We also need a way to, define the return type and the arguments, right? The number of arguments and the types of it. So I'm thinking, since we're defining a function essentially, it could look something like this. So we could have native add 10. We would define a function, in the same way that you would a function in KinoScript. And then this takes an integer, n, right? Well, we don't need to put that. We just need to put the type. And you can put as many types as you need. This only takes one, right? Or something like that. And since the strings are C-style strings, we can also just use C strings, and that will not be a problem. Not like that. And then the return type you put here as well, so it returns an integer. So you do something like that. And I'm thinking, put another thing before it. I'm not sure exactly what it would be, either DLL or maybe external, something like that. But I'll just stick with DLL since I already have that implemented. Then just one thing is missing. It is the file name that you are calling it from. Right. I need to. Right, and I am going to get as well to generating the code, but for now I'm just going to do it assuming you already wrote the bindings in C to call that. So it's going to be with that in mind, but in the future I'd like to generate it, right? There is a few problems with that as well, which I will get into. But I want it to look more like this, and then just the file name, I'm not sure where it would go, maybe just like this, you know? It's not necessarily ideal, but then you put this, because then we already have the stuff to parse this, you know? Don't need to replicate stuff. And it's consistent as well. So something like that I think would work. Yeah, it's subject to change, but something like that, and then yeah, I want to be able to do that, so if we could exit like that, then I think that's a decent way to handle it, you know? So you could define bindings for whatever C functions, C libraries, whatever you want, as long as you have the object file for it. And I think that would be alright. And then you can define more. You know? So if you have in here, you also have something like that, right? You get the idea. So to change this, I need to change this, right? So this needs to be an expression. And we do need to make sure that the types of the expression are correct. But yeah, we can just add this as an expression that we can parse in there, which actually, perhaps I want it to maybe even be different. I need to think. Not sure. So, hey, Alvez from NixOS. How you doing? How's NixOS treating you? Right, okay. Well, if this, yeah, if we parse it all like that, then I think it'll be fine. So we expect a string to be next, and then a comma, and then the function declaration. So I think we can call that. Pretty cool, nice, nice. Better than Arch, right? I believe you said that before. And I'm assuming you still think that. Okay, so if we have something like that, yeah, let me just get started on that and try to get that way. So, front end not C. So when we encounter when we encounter this one, we can parse it all. So that's the return type, but we need to actually handle this. So if the build, let me see where I thought this was. Right, it's an expression essentially. So I want to basically, if it is this DLM one, then I want to handle it a bit different, just a bit different. So let's see, we can still do this. Then I want to stop here. So if type equals built-in DLL, then there's gonna be some other stuff that I would do. And the return type can be the same. So I think everything else, right, so that stuff just needs to be there. So any other one's going to be like that, but this one's going to be a bit different. So I want to look at the next thing, and it's going to be a string, right? So the next token will be a string. So I could parse an expression and just make sure it's a string. Probably makes sense to do. So let's do, so I still want to do that. Right, so if I do this first, we can do that, and then we just need to make sure that the built-in value, the first element, is a string. The next thing we have to parse it a little bit different. So if, let me also assert just to make sure, like it should be from that, but I just want to make sure. Assert built-in dot value dot count. Let's put it in 0. Built-in expression value is not correct. Okay, something like that. Because I'm going to be accessing here, so I just want to make sure. Built-in .value.data 0 that type does not .data type, I think, does not equal type stir. Then we have an error, right? So we want to click, even do this. Print error. And we can do, let's see, we have a location. Well, we do have the token location, so I think we can do, let's see, set the current token. So let's do tokens 0. I guess we can use the expression action. So built-in.value.data 0 dot location expected string, but found view. Like that. Okay. And actually, I think I want to make a for this, so extra. This can be the. This is the file name, right? Equals data 0. And we can use that here instead. We can use file name. File name dot location, and actually, it's going to be. It's going to be an arrow, so There we go, because it is a pointer to it. So NixOS win? I probably won't. I don't know. It's pretty alright for me. Arch at the moment, so I'm not really concerned about that. File name. That value dot well actually I don't. I just need the data type. So really it's not a view, it's instead of string. Yep, F in the chat. Name dot data type, and this is data type, something like that. Okay, I might have messed up a couple of variables, but that should be fine. Now we have the token and everything, so it should be a comma. So it's actually here token type is not equal comma. Then we have an error. Yep, another one. Expected found token types and dot type. It's not finding any token type. And we can use token location. This is an arrow as well. Okay. Yeah, because we want a comma, and then the next one. So actually, this can be token consume. Consume, and we don't need it 0. Okay, and then the next one, so we can set token again after that. And actually, let me move this so it's more clear. So I want to consume that, and it should be. So you don't really need to set it as a variable, but regardless. Then the next one. Well, actually, the next one wants to parse function deck. Right, but it's really not a function deck. It's external function deck because we don't provide the names for it. Because that doesn't really make a lot of sense to provide them. So it's just right. So it's just the data types. So it's gonna have to be slightly different, but not too much different. So we should be able to do that. It has the tokens there, and we'll also need the parser as well, I suppose. Okay. If we parse that, then that's going to return running an OS on an external drive. Really? Is it NixOS that you're running externally? Is it like plugged in through USB? How does that work? That's going to return. It'll return a node. Yes and yes. That is interesting. How is the performance of that? External deck. Parser tokens. Well, okay, I guess we don't need a token because we can define it from the parser, so that's fine. So I am going to define it though. Token array tokens equals parser tokens on. And we'll probably need the arena as well, so that. Okay, so if we do that, we need to basically we're gonna expect an identifier, and that will be the name. So I'm thinking here. So the identifier is gonna be the name. So I'm willing to add a new node. Let me go to the depths. Right. So it's very similar to one that we have already, but it's gonna be different enough that I still think I need to. So no type. This will be type external func. External func, and the function call that will be essentially a built-in function. So I will not worry about that yet. We do have here is external func. Yeah. So node value x func. Alright. So do that, and then. The node, yeah, so that will be there. So we need something called xfunc. So type start. So it's an external func. So it has a name. And then it's going to have the arguments list, which is just going to be a list of data types. That way we can type check everything. So it's called type and types. So it needs to be let's even do that. Type. I think it could be that, so type. So it's gonna be a dynamic array. So it'll be easier to append and whatnot, and then we can capacity as well as the data. So type data. Okay, something like that. Then we also have the type return. Right. So all that should be all that we need for that. Well, we're gonna need the name as well, the name of the file. So that will be quite important. So well, okay, not for the external function necessarily, but for the greater thing, it's going to have that. So I'm not sure that we need that. Wait, I'm trying to think. So because that's really part of the expression generator. So I don't think we need it. So that should be fine. Let me show that compiles. We don't have any issues with that. So there's some issues. Right there, that is an issue. That's a string view actually. So let me go here. Alright, so there's a few things I need to fix. So this needs to be dot data. Okay, so end of non-root function, unused variable. Yeah, okay, so we should be good then. That should be fine. So we should be able to append the data types to that. Now we'll return the node. So the set the node equals that. Then node.type equals type external func. Yeah, and then so the node.value xfunc.name. Let me just create an xfunc, okay, so I don't have to do the dot all that stuff. So we'll do that. So xfunc.name equals, well, we need to check token stuff. So we'll do token name equals token peak tokens 0. Well, we'll token consume actually. Consume. We can even expect token. Expect token. Tokens, and we want token type item. So that will handle that for us. We can do that. Expect token, and then we can set the name equal to name dot I think. And then we can expect token. We don't even need to set it, so we can expect token type open parenthesis. And then we're going to parse everything in there. So we need basically just to collect the data types. So while token type is not equal, at close brain, we'll do this. So let me go ahead and actually set the token thing. So token equals that. So we start with the open parent, and then we're going to consume. We'll set token. Is set token tokens. Right. Tokens and token type. It's a type. I can never stuff. It's something like that. Which is the type. So int and all that stuff. Int and float and things like that. So we have that, and then we want to set once we basically append in the arena. I want to append to the x.args. I call it args. I don't remember. Let me actually check. 539 is where we're at. Types. Maybe I will change args. I think that is better. 539. And there we go. Alright, so we append to the args. I want to append not necessarily the token, but the type of the token. So token.value.type, I think is what it's called. Then we want to do well, actually, it could just be, we don't necessarily need like that, but we can do wall then we can do consume, and we can actually check the value of that. So if maybe I would do token consume tokens. Then we can look at it. So if token type does not if it equals token type close brain, then we will break. As if token type equals it's not equal token type comma. Then once you print error token application. And yeah, so just types token.type. Okay. There we go. Yeah, so that should work. So we do that, and then, hey, how you doing? What is up? What is up? So break. Implementing your own scripting language, or is it something like Lua? I am implementing my own. It's similar to Lua, but it is different in a few key ways. Let's show what it looks like. Let's see. So I guess the best example that I have at the moment. Hopefully I did not break it. Well, let's test it up here. Yes. All right. So that is Lua. So that it can write Lua now, so it turned complete or whatever. This is what it looks like. There's not good syntax happening at the moment. I need to work on that. But basically, we can define a variable. Where you put the name of the variable, a colon, and then the data type after, and you can set the value as well. And then an array is defined like this. Things like that. So it is statically typed. Working on a cross-platform TUI hex view editor application from scratch in C++. Nice, nice. Do you have a GitHub link for that? I would like to look at that, perhaps. It sounds interesting. Looks neat. Thank you, thank you. So, yeah, then we can set the, well, hang on. I'm not set the name. Okay. So we append to that, and then we need the return type at the end. Nothing public at the moment, just messing around, trying to get the render to work. Alright, alright. Are you using any libraries? Or is it just like all standard library stuff? So I need the token type colon. Then token type. Make a type, and then standard lib plus OS headers. Nice, nice. That is the best way to do it. I mean, that's how I like to do it. Okay. Equals value dot. Okay, something like that, and then set node dot value dot x equals x. And that is pretty much it. So return. Alright. A few issues. So unused variable fuck that. Oh yeah, so we don't use that there. And token is undeclared. And thank you for following. I appreciate that. Alright, how do you pronounce your name exactly? Is it Linden? I'm positive I messed that up. It's worth fun doing things from scratch, getting a peek of the black box things. Yeah, yeah, for sure, for sure. Linden, yeah, okay, okay. Wanted to make sure. I'm bad with names, so. Fuck that. Okay. Another person making their own programming language. Just yesterday had to relearn Java for an internship. Not easy to get a C++ internship. Decided to implement my own programming language for fun. Nice, nice. So are you making your own language in Java? Or what are you using to do? And also, what kind of language is it? Like, is it a compiled language, or a, or an interpreted language, or a bytecode language, something like that? Java courses. I had the option of taking C++ instead of Java, so that is what I'm doing. Correct. Okay, it's unused, so I need to use that. So, parse that. And we don't need to consume. That's pretty much it, right? So we have the comma, and then we have that, and that is the end of things. So, we can set the value of that. So, but it needs to be an expression. So that can be just a single expression. So perhaps they should return an expression. Simple simple interpreted language using standard Java 21. Alright, alright. And how is that? How is Java for language development? I've not used Java too much, and also not for a long time, so I don't know anything about any modern Java or much about Java in general. So I don't know how it would be for that. So that should be interesting. Need to set the value. We look at the built-in. So, what is that? So with me, a section of OOP is the heads use cases. Thought it would be far worse, but it was pretty straightforward actually. Alright. Java's been moving kind of away from OOP stuff, right? If I understand correctly. Like again, I don't know a whole lot about it. From what I've heard, it not necessarily moving away from OOP entirely, but it's been adopting some things from like functional and things like that. I could be wrong there, but I believe I have heard stuff about that. Let's return an expression. What if the whole thing could be same thing as C#? Optional static main. Yeah, for sure. I've seen things like that, yes. I don't know much about, haven't used it for ages. Indeed moving towards different directions. Notice they've added so many functional programming constructs in their standard library. Yeah. I say, it seems like a lot of languages are moving towards functional, at least in some way. And I think a lot of that is because of Rust. Yeah, like Rust isn't necessarily a functional language, but it has a lot of concepts of that. And I feel like a lot of other languages are starting to adapt that as well. Greetings, Pra. How you doing? Greetings and salutations. So maybe this should be an expression instead, and that would make more sense. But then that does, well, let's see. Parts, go to parts. So we get here. Rust is a great example. Would love it more if it weren't so strict on line times and unsafe things. Yeah. I agree on that. I think, yeah. That is one of the things, like, with Rust, where you have to do a lot of workarounds often. Especially if you're inexperienced. Parts, well, hang on. So the reason you're stuck in C++, yeah. Okay. Look at this building. Take the type, the value, and then the return type. So we could have dingly pointers and memory leaks for sure. Yeah. Seems to be quite annoying to deal with. Yeah, for sure. done anything at all with Rust. Yeah, I've not used Rust too much, but when I did use it, I didn't fully understand the lifetimes. Like, I get the idea behind them, but I don't get exactly how to use them. And it seems a lot of repetitive stuff to me. Things like that. Yeah. It has a lot of good stuff, though. Don't mind Rust, but need more like CPP with tons of esoteric features no one asked for. A million ways to do the same thing. Yeah. I agree. That is something I have noticed for sure. So the value, we need then, let's see, the experiment. But that's an optional parameter. So I really need to think I do that. I'll do it like that for now. So we need to set it to that. Where is that going? Yeah. Okay. So if we set that, back of C++, I keep most stuff in the style of C, but I take advantage of generics, operator overloading, etc. Yeah. That makes sense. I get that. Let's see. So we have that, and then set the return type. That should be pretty much it to generate. So if I do that, well then I want to add the file name. Do I necessarily need it as a value? Because, well, not really, because if we append it to the natives here, can't really do that here though, because I don't have the machine, so I can't do that. Interesting. Entire OOP thing with inheritance just gets messy. Traction hell is a sad thing. Yeah, for sure. It seems, OOP, it seems like a really good idea, but then actually using it, a lot of times, at least in my experience, it's not great. Not great. Okay, so we have that, and then, well, I guess I want to add it to the symbol table. As a built-in, yeah, we could do that. Okay. Hit 7 place on paper, yeah. Kind of like the approach CPP did. Once I got past, it was pretty straightforward for me to catch on with it. I feel like the lifetimes would be much harder to track, especially if your code base grows bigger. Yeah. So let's see. Let's look at. So we have that. What do I actually add one? So symbol, we set it like that. Okay, so I want that for sure. Right here. Add it as a external, right? Got a trick question. Is there a way to find the answer of a quiz? What? I did not understand the question. Got a quick question. Like through a Canvas assignment. Pure solid is solving problems that don't exist yet. Yeah. You mean you have a quiz and you want to get the answers for it? Like you have, I'm assuming it's a quiz for school or something? Not. What symbols do we have? Let's look at that. Yeah, I don't know, that's a good idea. Right, how about next? Rules file name. Well, okay. because it is an expression, but it could just be a string, right? Because we'd rather have it as a string, so I think it makes more sense. So, yeah, so let's do that. It's back in here. I'm not going to play Murder the Police, but Google is the best friend of an internet user. Yeah, that probably makes more sense than going into random Twitch channels and asking for answers to quizzes. To Google it. That makes a lot of sense. Type string. Dot string, something like that. Alright, let's see if any random files. Does not. Let's just return that directly. Reset anything else here. Reset that. Yeah, I don't think we need to return it. Just return it directly. That makes sense, yes. Okay. Stream buffering, please wait 5 to 10 seconds, then buffers. Is it? Let's see. Let me look on my end. It is. Okay. That is unfortunate. I do not know why. The connection seems fine to me. The bitrate is alright. Maybe try refreshing, I guess. I'm not sure. Ooh, it is dropping frames, so I see that. Let me see. Might be that. Maybe. Because, like, my internet connection is fine right now. Sometimes it's not good, and it is because of my internet, but, it is fine right now. Yeah, I apologize. I do not think there's anything I can do about that at the moment. Next funk does not exist. Look at that. Oh yeah, let me know if it gets better. Hopefully it does. Oh yeah, so right there with the file name. And that is 2. So we can use the token. Well, do we have? Yeah, we have. Alright, let's send this to a token. So let's set that. There we go. Wait, Vim shows the mode twice. Oh, this is not Vim. This is my own one, and yeah, the view got messed up. There we go. Now I won't say that. Yeah, it's my own text editor. It's called Kano. Yeah, it has a few visual glitches like that. That is why it said that. GitHub link. Oh, yeah. Okay, no, there we go. There we go, yes. It does look a lot like that, and it is obviously very heavily inspired from it. We don't need this anymore. Also, I did that wrong anyway. Putting the script language for the editor, yes. That is the goal. So I want to embed it into the editor, so it's like sort of like Lua for NeoVim or something like that. Yes. But I also want it to be general, at least somewhat general purpose as well. So it is a pointer. Yeah, symbol X does not exist, so I need to add that, and then it's undeclared. Okay, so symbol, I need to add the symbol X, and then we have symbol value as well, which is right there, so that should be good then. So that does compile. So should be able to have a few things that we need to do. So it is this one. So we don't need this value count because there is no value used at the moment. So we don't need to do that. Instead, we need to basically add it. So we need to load the library for the name. Yeah. Okay. So we need to push the name. So do we have that? Okay, so we do have gen push there, so we can use that. Build its own editor, then build its own scripting language for it, while also using an editor to do it. Yes. His own C compiler. Interesting idea. Okay, so I need to use gen push string state as well as built-in dot built-in dot name. So do we have the name still? We do not. We need to do that. I think that makes sense then. Dot file name. You put that. That is important. C compiler with scripting language support out of the box. Interesting. Seems like a big task. We have that on the stack. Then load library. Alright, we don't need to do this though. So load library. Well, actually, what does the load library consume? Let me look at that. Okay, it needs the lib name as well, so I need to do that also. Or the function name. Just the regular name. So both those, and then they get consumed, so that makes sense. Okay. Back to here, though. Parts built in. Let's see. Start that here in Windows. I haven't really used Windows for much development like that. Mostly like JavaScript stuff when I was using Windows. So I don't know how that would be. It's code for clearing the screen. Doesn't actually clear the screen. Bruh. That is unfortunate. Not a big fan of Windows. File name. So we can set it's file name. Right. String. Okay. Then we need the file name again. fail name. Okay, something like that. Okay, so we don't have that. Reboot into Linux 4i to the partition. Alright, alright. The thing doesn't exist. What do we have then? Expert value. Okay. Value.built-in. Okay, so we should be able to parse that. Assuming all goes well, so I'll get rid of that. This should work though. So we have the string for the file name. Then the declarations. Let's try that. Expected token. Okay. Hmm. That is here, so it doesn't like that. Interesting. Certified Microsoft Windows for real, for real. I did something wrong here. Let me look at the function. Yeah, so it's not from that. It's down here actually, so they token that. It's not. That is okay, the value's not correct. That is something better, so I don't know what that was about. I think there's an issue with the editor. Yeah, so we don't need to assert that because that is outdated. Okay, so we compile. I'm gonna try call tank. Okay, so that does still work. So it does load, and it is a nicer syntax. Still not necessarily final, but it is better. So yeah, and we can also perform type checking as well once we get to that. Yes. Okay. So changing this, yeah, it's not going to change anything. Let's say make it a string. But it will. That way we can check the types and ensure that the arguments are correct and things like that. I think I would make this thing. So, it's for very unexternal action. Okay, sure. We're live. Welcome back. What Linux distro are you using it? Curious to know. Okay, so that works. So then we append that. So we need to check if the symbol is one of those. If it weren't for the poor support of multiplayer games, would have switched over like a decade ago. Right. Yes. Like for me, I do not game very much, so that was not really a big deal for me. It makes it a lot easier to switch. So I don't really ever have to use Windows. I don't even have it installed actually on my computer. Okay. One, two with a customized GNOME theme. Nice. Okay. So find the expression. Okay. Yeah, so it's going to be considered an identifier. OSU, and that one's really well underlined. Nice. What is OSU? I have heard of it, but I don't remember what it is. Yeah, I have actually looked it up before. This one, computer rhythm game. Yes, okay. I am uncultured. Okay. This can be treated as an expression. What's expression? I want to look at. Yeah. So if it is an identifier, then we want to look it up basically. So if it's an identifier and it is in the symbol table, as a built-in, then we want to parse it as a built-in basically. So basically, we want to just parse all the arguments, comma separated, and then call it. Not necessarily built-in. I guess built-in is not really the best word, so it's really external as an external. Right. Built-in is ones that are built-in. Right. So instead of call, it would be the name of that, right? Because that gets added to the symbol table as an external function. We just want to parse the arguments, and want to also check to make sure the number of arguments are correct and the data types for them are correct as well. So this would be valid, and then we can also check the return type. So something like that. I'm gonna be right back. Yeah, give me about 3 minutes, and I'll be right back. Whoops, I am back. I accidentally pressed something. Okay. That is why I went black for a second. Okay. Let's see. Yeah, so it's gonna be like that. I do need to change one thing, I realized. So let's go. I do the symbol table, right? This needs to actually be. This needs to be the entire X bucket, like that. That is what we want to append. Right there. So yeah. Equals that, so I do need to change the depths. I don't know if I have it actually here. We need to right, that is wrong. I spelled it wrong. Next. There we go. What? Oh yes, called fun deck. Let's see the explorers. And then that will have all the information because that has all of the data types and everything like that. So yeah, that's why I need to change that. And let's see what else. This could be an ident as well. Instead of a string, we could just use the ident value, and that might make it look nicer. Let's see. But instead of that, it could be. Well, I'll just have it like this for now. Right. Just have an object file that you bring a string. I'll leave it like that, and I can change it later. So let's go to parse primer. So if it's an identifier, and so if, well, we can just do, this can be something else. If that, and then if let's see, so if is func. So that will just basically search those. So parser and then token dot value dot length is that. Then we will parse that. So nice. Okay, so we do that. Let's actually compile. Is X func? Yeah, so we don't have that. So let's define that. Go here by the get bar. So it takes the parser, and a string view. This is the name. Okay, so folder 0. So we loop over this. With that type equals symbol x, and compare it. So it's gonna be go like that. Okay, and that is same as name, and return that. Right, but not bar, now dot. Well, we can just return true. Do you want to return it, or actually, I guess returning it would probably be better. Yeah, I can return. Whoops. This can be yeah, next func. I can return next func pointer. Return the pointer. Dot func, and that's not great. And then otherwise we can return null. So check it is null. Next func is not equal null. Maybe we can define it here. So next because I don't want to have to loop over flex, right? So if it's that, there we go. It's not equal. Okay, something like that. And let's see if I compile. It does not. I need to be a pointer. So it doesn't like that. Oh yeah, so that is wrong. 594. That is not underscore. Okay, yeah. So I know that is wrong there. I need to do this. Whoops. That, and this is a bit of a long thing here, but there we go. Okay, like that. And no X func. Okay. I'm just called X. I always forget the names. I put the things. Alright, that's what it was. So if I go here, and if we call this, it should assert func. Yeah, well, no, that is the wrong thing. That is, oh, that is wrong. Get far. So trying to get the variable. Huh. And the location is past there. That is interesting. Is it from that? Yes, okay. So if I do 10, I have to do with that. It doesn't like it as a statement. Huh. Okay, that's interesting. Maybe I wanted to run in GDB and I can follow through and see what it says. So run, okay. Well, I want to break on parse. And I'll just step through and see where we get to this point. Okay. So see where we call get far. So this is exit. So alright, actually I forgot to step into it. So let's go to where it's exit. So it is in the exit. Obviously, we already do that. So that parse thing. So we go in here. press to continue and not S. Okay, so I'm not very good at jigging. Let's start over. Step. Go through here, and we get that. Consume. Parse expression. So I'm assuming it's in here. Alright, so step into this one now. Parsing this. It should be an identifier. Is null. Okay, so that's not right. So it did not add it to the symbol table properly. Why is that? Or it did not get it properly. Okay, so alright, let me look at it again. Get X font. Let me look at that. So let me run it again. And let's see the name. Is that okay? That should be right then. And then cursor.symbols.cat is 1. Okay. Cursor.symbol.data I dot I is that, and then print cursor symbols.data I dot val. Oh shoot, I see what I did wrong. Val dot next. There we go. Okay. Yeah, so I checked the wrong value there. My bad. Okay, there you go. Now it actually failed in the proper place. So right here. So here we want to parse an X font call even. And we can pass the X font there, and then we'll be able to check everything and everything like that. So at the end of this, yeah, we do that there. So that should be fine. If I do that as well, then the location should be better. Should work properly. So yeah, right. If we create this function, parse X font call, I'll put it here. Yeah, so it has the parser and then X font. Just be a enter. Alright, so fun. So there's a few things that we need to do. So we want to, right, we have the identifier, and we know that's right, and I'm pretty sure that gets consumed as well. Yeah, so we consume it. So what we have is we just need to basically parse the expressions as many times as that calls for. So, so I think we do for it's less than func I plus plus, and we can parse expression. Parser. I don't remember all of it. I think just that. So we parse the expression, and then that is, yeah, so we can return that expr equals that. So we return the expression, and then we want to add it to, well, all right, we're creating a thing here. This is going to return an expression and stuff. So yeah, so this is like it's like a built-in essentially. So we actually go back to the first X font call. That's going to be the expression. And we set and we'll set the location as well. Okay, something like that. And we want to set it all to that. So the type will be expr ext, right? And then yeah, something like that. Okay, so basically we need to do a similar thing that we do for the regular function call. So I can probably count that as a starting point. We don't have to make this a separate one, we can just do that. Okay, we do have set location. Yeah, so I'll take this. Whoops. Use that as a starting point. So get func. Not get, but x. Okay, let's see. So it's not exactly the same because we know how many arguments it's going to be. So we can get rid. Well, we want to set the expression. We'll create one equals how do I allocate it actually here? Yeah, we need to allocate like that. So that's what we need for the expression. And we can start with that. We'll get back to this. And want to set height equals x per x, and then x per so this is the x call, right? Well, x per value dot x dot name, right? So it's basically the same thing, but it's gonna so equals the, well, we don't need the name here. Okay, let me think. So the name is a bit different. Something we need to keep track of also is the number of them that we have, and we need to use that when we're calling. So we'll need to get that. But for now, the name, I guess, could be set. Well, okay. Yeah, okay, I see. So the name will already be set, so we don't need that. We need to set before. Get this to look better. Okay, so let's see. So the function, we don't need to do that because we already have the func, right? So we need to basically iterate over these. We want to add that to the value of it. Okay. Closer again. We want to append to the expert pointer, right? Expert value dot x dot it's really the args first expression dot function. Then if, well, let's just say a token reveals token consume, well, okay. So token what's your token? We expect a it's set on the left. So if I equals, it's not equal 1, then we want to do this. Otherwise, we're at the end, so we don't want to do that. So yeah, we're expecting all that. And that's just going to append the arguments. And that's really all that we need, I guess. We don't really need to copy this. We have that. And everything else, yeah. So that, everything else is already set up. So I think, right here, we want to set actually x.name equals token.value.item. And then x for x. Okay, the rest of it needs to be this. Okay, we'll do this, say x equal to that. Alright, so I'm going to actually change this, but then we can set the name equal to that. Alright, so call. So instead of returning an expression, let's just return an x func call like that. We don't need the expression. So let me set this down there. Yes, we don't need that. We just need an x func call equals that. Append to this, so whoops, I need to do X, okay. Append to X. X args. And that is it. Return X. Okay. X. Set equals for X and yeah, okay, so that's pretty much it. We need to check the type as well, but we'll get to that. Set the location. Okay, yeah, that's pretty much it. So we need to define this. So do X func, and we'll make X func call, which is similar. Call. But we don't need the file name. We do need the name. The args are going to be expers, number of expressions, and then the return type. I don't know. I think we might still need that. Not really. No, we don't need that. Okay. So we have that basically. Because the return type is already known in the other one, so we don't need that. So that's really all we need. Let's go through some compiler errors. Expert has no member. Yeah. So expert. Yeah, so do expert X. Expert value, so we need X call X. And yeah, okay, so we have that. Should have that. Oh yeah, it's value X, okay. So no one. Value.x. Okay. Location undeclared. So, we don't have the location. What is it? Token location. Okay, we can set that. We don't need to set that again. We set it there and good. Okay, so we have that, and then we cannot compile it yet. But I'm not sure we have everything. So we have the function call. Right. Okay. So the only thing that we're missing is when we create. Yeah. Okay. We'll get to that. So let's see. In the backend, parts built-in. Let me look at that. At Gen built for that. We have this one. So we push those, and I want to append this. Append that to basically the list of X's. Because we need to know that. So we want to have the number. Yeah, okay, let me say that. So let's go to here. We have the parser. So we need a list of these are X numbers. And we'll define that. So X numbers, and it has X data. So, well, do we really need? I guess we don't need that. So we just need we have the numbers, and then we have the name. So string data. So that's what's gonna be, and then we can use the count as the number. Because the count plus 2 is what the number will be, because we got 2 built-in ones. But basically, if you don't know, the bytecode for the virtual machine, it has this feature where we can do basically a native and then a number, and that will call one of the native functions. And this is what we use to call the external libraries. So if you call native 0, then that would be write, or native 1 would be exit, and those are the native ones that we have. So we need to do plus 2 always. So if it's the 0th one, we would add 2, and that would be whichever one you add. So that's how we can keep track of the ones that have been added. We just need to compare it to that, essentially. Hopefully that made sense. Let's go back to backend. Gen. And let's see, so we have this, and then, yeah, so I want to append to, I added it to the wrong thing. State X, and I want to append the external value.build and .x.name. Append that. Yeah, so I need to add it to the state, not to that. So parser, get rid of that. State. Yeah, the state must not be defined again. So let me grab this. I guess it is in the backend header. Yeah, program state right here. So let's put this here. Whoops, that's not right. Put that there. Next numbers, X, and go back to here. So get rid of that. We do not need that here. Okay. Where is it's up? Alright, so that should work. If I build that, it does work. Okay, gen built in. So now, now we need to add the expression generation, right? Let's see. Yeah, so then we'll pin to that, and that's how we can get that. So we can basically loop over these, and then we'll know which one to call. Right. So gen expression. Right, so case of expr of x. I want to. So this will be the string view name. There's expr value dot x dot name. Then we have the array thing. So we need to generate the array. So for something value 0, the array is expr value dot array dot count. Gen expression. So expr value dot array dot data I. So we'll generate that, right? And then we have all of the things on the top. So then we want to call this function. So we can call it. We need to get it from there. So we can iterate over is less than state x dot count plus. And then if we compare state x dot data I is the same as expr value as the same as name basically. Then we can do stuff. Get to the end and want to just I guess we can return it here. I don't know. We'll get to that. So we'll put something there. But if we do this, then we want to call that one. So we can generate an instruction here. We have an example of it. Let's just maybe make one. So gen native. So we want to pass the state as well as the number that we're going to use. So that's going to be I plus 2 is the number that we'll use for the native call. And then we want to do state stack size minus equals state value dot count. That's not right. Then we can break, and if we get to the end, we want to assert false. Something wrong with the external function. That okay. View arg. Okay, something like that. So yeah, we shouldn't ever get to that point, basically. So gen native. So let's go to a different gen. So gen push, and we'll use that one as an example, I suppose. Gen native, so we need that, and then the value. Yeah, so it's basically the same as this. So as in equals value is inst native. And we do not need to increase the stack size. Let's consume it, but we don't know. Yes, sir. In type. Okay, so that should be pretty good. Let's see if that compiles. Okay, state has no member in the value. Yeah, it's X. Wait, what? Yeah, expert. So then that text. There we go. X dot X. Where is your language at now? I can show. So basically, the most complex example I have at the moment is Wool 110. I do not know if you've seen it before. I wrote it quite a while ago. I haven't wrote anything more complicated yet. But yeah, so I wrote this. It's a bit outdated because there is a few things I've added since I added it. But yeah, basically, we can define variables like this, and then arrays like that. Structs, we do have structs. They need a little work. The structs are a little bit iffy. Functions are like this as well. Yeah, this really uses most of the features. Because the most recent feature that I added here is structs. And then one that I'm working on right now is the ability to call C code. That you can define. The user can define it and then call the C code from the scripting language. Yeah, that's pretty much where it's at. That's really most of the features that I really wanted to implement are implemented. So now it's just sort of ironing them out. Well, once I finish this, calling external functions. Cool, yes. I mean, there's maybe a few more features that I will add, but for the most part, you know, what you need, at least. Wait, so it does that, where are we at? Dot. Parser does not exist because it is state. What Ubuntu are you running? I'm not running Ubuntu, I am running, Arch Linux. Okay, let's try that perhaps. So, yeah, that should work. Insertion failed. Okay. Did not work. Yeah, I did not like that. Oh, what was the issue? Perhaps I will break all of these. You are X AI and you are try that and print them all out and see what we get. They are the same. Oh shoot, I see. Because I broke out of this, but then, yeah, that is a mistake. So, yeah, I guess that's not really going to work, is it? So, I'm a little stupid. I need to, I don't know, I guess I'll need to think about something else with that, but, yeah, so that will actually work, just, okay, now if I run it, it did actually work, okay, so we define that, we don't check the types just yet, and the arg count and whatnot, but yeah, so we have this file, so I should be able to change it and add another one, so let's make, sub 10, right? Maybe this one will be sub 10, sub 10, and minus 5 k 20, so it's not even right. Okay. Subbing 10 from sub 10, native sub 10, so make it pop it, and then sub 10, and that's really it. Okay, so I do that. I recompile it, so I think those are the flag, and then shared. So it's a no character. Let me get rid of that. 6. It's like that. Okay, so it's compiled. If I define one for that, sub 10. Read this, let me try that. So we do that, and then if we call sub 10 instead, it should be 0. Okay, there we go. That is pretty cool. So we can define functions, external functions like this. So it's a little, the syntax is not finalized, but basically DLL followed by a string which contains the name of the file, of the object file that you were calling, and then the function name, the arguments to it, and then the return argument, and then you call it like this basically. It's wrapped in parentheses, so there's not really a way to call it like this just yet. Nothing. Well, actually, that might work. No, it doesn't like that. So I need to work on that. That's just a parsing issue. We can call it like this, so you can exit or well, I guess exit's the only one that would really work like that. But yeah, so we can do that. Well, I think we could do exit X. Will that work? Does not work. That's interesting. Doesn't call it. Okay, that's a bit of a weird thing that is going on there. It just ignores this. Okay, yes, there's a few issues with that I need to look into for sure. If I do add that. That works, okay. It looks like that, but not when defined that. So that's a really weird issue. I'm not sure why it does that. I will look at that. But yes, that's really the only way you can call it now. Obviously, I want to be able to call it just as a statement like that. So I need to get to that. But otherwise, let's see. Yeah, so the return type gets returned properly. It can also be void. If it was void, then I think I would set it to void. So I think this would be like an error. I guess it still would. So I'm not sure why that would. But that would throw an error anyway. So I'm trying to set something to a void function. But let's see. That's pretty cool. So in the future, I would like to generate it because basically right now you need to write these wrappers. That look like this, where basically you interact with the virtual machine by pushing and popping to it. And obviously that is not ideal. So this is not very hard to generate though, because basically you just generate these pops, right? Which pop arguments on stack based on whatever the arguments to it are. And then you want to check. I don't check it, but you want to check the data types of it, which you can check that. Make sure they are the proper types when you pop them off, and then if not, throw an error. And then just call the function in here and collect the result if applicable, and then push it essentially. So it's not very hard to generate this. So that is planned, but I'm not implemented that yet. It's for working with ELLs. Okay, I will push that. Then I do actually have to go now. Yeah, but making good progress. We are getting there for sure. Very cool. Alright. So, yeah. I need to place this so I can actually check that. So, I will get there. I will get there. Okay. I think. Yes, that's going to be about it. So, thank you guys for watching, and I'll see you next time. Goodbye.